study rule. So in the previous lecture, we started a new chapter of mathematics, that was direct and inverse proportion. And I taught you the first part of the chapter, that was direct proportion. In today's video, I'll be teaching you the next part of the chapter, that is inverse proportion. Now, direct and inverse proportion. Just like the name suggests, it sounds opposite of each other. Yes, it is. Somewhere, direct and inverse proportion are opposite of each other. Now let's get into the video to get a clear idea of inverse proportion, and we'll be comparing it with direct proportion, solving several numerical problems. Let's get started. First things first, what is inverse proportion? I'll explain you in simple terms. Just consider two variables x and y. Now consider two cases. In the first case, the value of the variable x is increasing due to a corresponding decrease in the value of the variable y. And in the second case, the value of the variable x is decreasing due to a corresponding increase in the value of the variable y. That means x is increasing, y is decreasing, or x is decreasing, y is increasing. That means the opposite things are happening in both the variables. Now let us consider an example. Let's say we have to travel a distance of 20 km and my speed is 10 km per hour. So the time taken to travel this 20 km will be 2 hours because my speed is 10 km per hour. In 1 hour I can travel 10 km, so I will take 2 hours to travel this 20 km. Now let me increase my speed. If I increase my speed to 20 km per hour, then I'll just take 1 hour to complete this 20 km distance. So what is happening is, there are two variables. One is the speed and the other is time. If I'm increasing my speed from 10 km per hour to 20 km per hour, my time is getting reduced from 2 hours to 1 hour. Now, let us consider another case. Let me reduce my speed from 10 km per hour to 5 km per hour. Now, if I have to travel the same 20 km, I'll be taking 4 hours because 4 times 20, I have to travel this 20 km distance, so it will take me 4 hours. So what is happening? When I am reducing my speed from 10 km to 5 km, the time taken is getting increased from 2 hours to 4 hours. So if there are two variables, x, that is the speed, and y, that is time, and x is increasing, that means the speed is increasing, then time is decreasing. If the speed is decreasing, that is from 10 km per hour, if I am decreasing my speed to 5 km per hour, my time is increasing. So in this case, x and y are said to be in inverse proportion. So this was inverse proportion and the relationship between the variables when they are in inverse proportion. Now let us observe an example that has been given over here. So we have speed in kilometer per hour and time taken in minutes. So let us consider the speed in kilometer per hour as a variable x and time taken in minutes as a variable y. Now when we are walking, then our speed is 3 km per hour and the time taken in minutes to travel a particular distance is 60 minutes. So if my speed is 3 km, I am taking 60 minutes to cover that distance. Now from walking, I have shifted to running. So of course my speed will increase. My speed increases from 3 km per hour to 6 km per hour. Now what will happen? If I am increasing my speed, automatically the time taken to cover a particular distance will decrease. So what is happening? That the time taken is getting reduced from 30 minutes to 15 minutes. Again, from running, I am shifting to cycling. So my speed again is increasing from 6 km per hour to 9 km per hour. And my time will get reduced from 15 minutes to 10 minutes. Now if I start traveling by car, my speed will increase to 45 km per hour. And time will reduce to 2 minutes. That means it will just take me 2 minutes to reach a particular distance. Now, what are we observing from this given example? That these two variables x and y are in inverse proportion. Why? Because x is increasing and y is decreasing. But this is not the only condition for inverse proportion. We will study another necessary condition for two variables to be in inverse proportion. It is not that if x is increasing and y is decreasing, then every time it will be in inverse proportion. There is another condition that needs to be satisfied, and we will study that condition soon further in the video. Now, just make one observation over here. When the speed is increasing from 3 km per hour to 6 km per hour, that means the speed is getting multiplied by 2. And the time, it is decreasing from 30 minutes to 15 minutes. That means the time is getting somewhere divided by 2. 30 divided by 2 gives us 15. Or we can say that the time is basically multiplied with 1 by 2. You can say in both ways that either the time is getting multiplied with 1 by 2 or divided by 2. Same thing. So it becomes 50. Again, from 3 km per hour when I'm shifting from walking to cycling, my speed is increasing and it is becoming 3 times. Because 3 multiplied with 3 gives us 9. And my time taken is getting reduced from 30 minutes to 10 minutes. So basically what is happening? This 30 minutes is getting divided by 3 and it is resulting in 10. Again, when my speed is increasing from 3 to 45, that means it is getting multiplied by 15. Speed is getting multiplied by 15 and 3 multiplied by 15 results in 45. My time will get divided by 15. That means if I have 30 as my speed initially and then I increase as my time initially, and with the increase of speed my time will decrease, that means time will also get divided by 15. And when 30 is divided by 15, we get 2. So this means that if the speed is getting multiplied by 2, time is getting divided by 2. Speed is getting multiplied by 5, time is getting divided by 5. So this is the observation that we made from this table. Now let us try to draw another conclusion from this question. Just consider x1. x1 over here, that means the first speed is given as 3 km per hour. And y1 is the first time. That means the speed, the time corresponding to this speed, it is 30 minutes. So y1 over here is 30 minutes. Now let us take the product of these two. That means x1, y1. So x1 multiplied by y1 over here gives us 3 multiplied with 30, which is equal to 90. Now note it down. This is 90. Now we'll be calculating the product of these two variables, that means x1, y1, we have already calculated. Now we'll be calculating for x2, y2, x3, y3 and x4, y4 and observe what is happening. So in x1, y1 we got the answer as 90. The product of the two variables gave us 90. Let's calculate for x2, y2. In case of x2, y2, we have x2 as 6 and y2 as 15. So we'll be multiplying 6 with 15. And 15 multiplied by 6 gives us 90. So this is 90. So again we got 90. Let's check what's the case in x3, y3. So when we have x3, y3, we have 9 multiplied with 10. 9 multiplied with 10. So again we get 90. And last but not the least, we have x4, y4. That is when we are traveling by car. So in case of x4 multiplied by y4, we have 45 multiplied with 2. This again gives us 90. So from here we can draw a conclusion that if we have two variables x and y and they are in inverse proportion, then the product of the variables x and y will be a constant number. Over here 90 we are getting in each case, so the product is a constant, that is 90. So we can conclude that if two variables x and y are in inverse proportion, then this product, that means the product of the first variable with the second variable, will be a constant number k. This is a very important conclusion and a necessary condition for two variables to be in inverse proportion. Now let us consider another example of inverse proportion. A school has a maximum of ₹6,000 to spend on mathematics textbook. Okay, just consider that. I am the authority of the school and I have maximum of ₹6,000 to spend on mathematics textbook. Now, the first observation that has been given to us is that ₹40 is the price of each book. Now, if ₹40 is the price of each book, then how many books will I be able to buy? The total amount that I can spend is 6,000. And ₹40 is the price of one book. Then the number of books that can be bought can easily be calculated by dividing these two quantities. That means 6,000 divided by 40, because 40 is the price of each book. So the 0 gets cancelled up and we have 4 1 times, 4 15 times 60 and 0. So when the price of each book is rupees 40, then the number of books that can be bought is 150. Done. This is the first observation that was given to us already. So let us consider that this is the variable x and this is the variable y. Again, in this case, we have two variables, price of the book and the number of books that can be bought. Now, what I'm doing is, if I increase my price, that is the price of the book, from rupees 40 to rupees 50, 40 to 50, what you do is just apply your basic common sense at first. If I'm increasing the price of one book and the amount that I have in total is fixed, that is, I have 6,000, I cannot increase that price, then the number of books that I can buy will of course decrease because the price of one book is increasing. So the number of books will decrease. So X will increase and Y will decrease. Okay. So if I'm increasing the price of each book from 40 to 50, now how will I calculate the number of books? What I'm doing is I have total 6,000 rupees and now the price of per book is rupees 50. So the number of books can be calculated by dividing these two quantities. So when I divide it, 0 gets cancelled out with the 0. 5, 12 times is 60 and 0. So I get 120. That means if now the price is rupees 50, I can purchase 120 books. Again, the price of book is increasing from 50 rupees to 60 rupees. Now let's calculate the number of books that can be purchased within the same amount, that is 6,000. And the price of each book is 60 rupees. 0 gets cancelled out with 0, 6 gets cancelled out with 600, leaving behind 100. So in this case, we'll be able to purchase 100 books. Now if the price increases from 60 rupees to 75 rupees, then I'll be multiplying 6,000 I'll be dividing 6,000 by 75 in order to calculate the number of books that I can purchase in this case when the price of one book has increased to 75 rupees. So what happens is 15 5 times 75. 15 4 times 60, we are left behind with 2 zeros, 5 1 times, 5 8 times 40, 0. So this gives us 80 rupees. Now again the price is increasing. Oh my god. From 75 is getting to 80 rupees. Now let's calculate how many books we'll be able to buy in this amount. So it's 6,000 divided by 80. 0 gets cancelled up. 8 1 times 8, I'll write like 4 2 times 8. 4 1 times 4 and then 25 times 0, 150. So 2 gets cancelled out with 150, leaving behind 75. So we'll be able to buy 75 books in this case. Again, the price will increase and it will become to 100 rupees per book. So the total amount that I can spend is rupees 6,000. Per book I have to spend 100. When I divide both the quantities, I'll get the number of books. That is the 0 0 gets cancelled up and I'll be left behind with 60. So 60 will be the book that I'll be able to buy, like 60 number of books. So what is happening? Price is gradually increasing one after the other and thus the number of books that I can buy is decreasing. Now, how to check that whether these two quantities are in direct proportion or are in inverse proportion or not? This is happening. Price is increasing, variable X is increasing and thus variable Y is decreasing. But is this increase and decrease taking place correspondingly and in proportion or not, we have to check. So the necessary condition that I taught you was that the product of these two variables should be a constant number. So when I multiply 150 with 40, we get 6,000 because this 150 came out by dividing 6,000 with 40. So when I multiply with these two quantities, then what will I get? When I multiply these two quantities, I'll get 6,000. That means 150 multiplied with 40 gives us 6,000. Again, when I multiply these two quantities, that is 50 and 120. 120 and 50 again gives us 6,000. In the third case also 60 multiplied with 100 again gives us 6,000. And similarly, in each of the cases, we will be getting the product of these two variables as 6,000. So from here, what we can conclude? That the product of the variable x and y is a constant number k, which is basically over here it is 6,000. This is a constant number. So x and y are in inverse proportion because x is increasing, y is decreasing, and the product of the two variables in each of the case is a constant number. I hope your concept is clear about inverse proportion. Let's solve some more problems to clear it better. Now, from the previous two examples that we solved, we have drawn a conclusion that if we have two quantities that are represented by the two variables x and y, and they are in inverse proportion, then what is the necessary condition? I hope you all remember. Tell along with me. The product of the variable x and y will be a constant number k. So this is the relationship between the two variables that are in inverse proportion. This is very important. Now, let us make some simplifications and conclude something else as well. Over here, if I have xy is equal to k, let us consider the first part. That means the first case. In the first case, the value of x will be x1 and the value of y will be y1. And in the second case, the value of x will be x2, third case, and y will be y2, in the third case, x3, y3. So that is the thing. So first of all, draw a conclusion from over here. If x multiplied with y is equal to k, that means this product is a constant. So the first observation will be x1 multiplied with y1, and the second observation will be x2 multiplied with y2. Now, what we'll do is we will take this y1 on the right hand side and we'll take this x2 on the left hand side. So when x2 comes on the left hand side, it will get divided by x1. So we'll get x1 divided by x2 on the left hand side. And when I take y, this will be y2, the product of x2 and y2. Now, if I take y1 on the right hand side, it will get divided by y2. So I'll be left with y2 by y2. Now, from here we can say that the first conclusion was that the product of the variables should be a constant. That means x1 y1 is equal to x2 y2 is equal to a constant. And the second observation is that if I take the ratio of the first variable, that is x1, with the first variable of the second observation, that means x1 is to x2, or we can simply call it as x1 divided by x2, then that will be equal to the ratio of the second variable but taken in the reverse order. That means x1 divided by x2 will be equal to y2 divided by y1. Got it? Similarly, if I have another variable like if I say x2 and x3, so x2 divided by x3, if I am taking the ratio of x2 and x3, then that will be equal to y3 by y2. Are you getting my point? When we taught direct proportion, then there we had that the ratio will be constant. x1 y1 will be equal to x2 y2 will be equal to x3 y3. The only difference in case of inverse proportion is that this ratio x1 y1 will be equal to the ratio of here the ratio will be of the first variable, that is x1 and x2. In the previous example we had x1 by y1. Here the ratio will be of the same variable x1 by x2. But this will be equal to the ratio of the second variable but taken in the reverse order. That means x1 by x2 will be equal to y2 upon y1, and this is a constant number k. So this is a very important conclusion, and you must remember to check whether two variables are in inverse proportion or not. Now I have an example over here. We have a square sheet of paper and there are total 48 counters. And we have to arrange it in different combinations of the number of rows and number of columns. Now, it's getting confusing. Let me explain you with a simple example. Just consider that I have 6 students and I have to arrange them into rows and columns. Okay. Now, if I arrange all the 6 students in the first row, that means the number of row is 1 and I'm arranging all the students in the first row. So, there will be 6 students, all 6 students in the first row. So, the number of column will be 6. So, 1 row, 6 column. Now, let me increase my number of row to 2. If I increase my number of row to 2, then there will be 3 students in each row. So, the number of column will become 3. Now, if I again increase my number of row to 3, then there will be 2 students in each of the rows. So, the number of column becomes 2. So, what we are observing over here is when I am increasing the number of rows from 1 to 2, then my number of column is getting decreased from 6 to 3. Again, on further increase of the number of rows from 2 to 3, my number of columns get decreased from 3 to 2. So what is happening is this number of rows and number of columns, they are in inverse proportion. As the number of row gets increased, the number of columns gets decreased. So this is the basic concept. And let me explain you another thing. This 48 that has been given over here, that means 48 counters. This means that when you make the product of the number of rows and the number of columns, this should give you 48. This is the main concept. Like if I have 6 students and I have arranged it in 3 rows and 2 columns. When I multiply 3 with 2, I get 6. So this is the case. When you take the product of the number of rows and columns, you will get the total number of counters. Now the question over here is, we have been given the number of rows, number of columns, and we have been provided with 2 data. First one is that when the number of row is 4, then the number of column is 12, and when the number of row is 6, the number of column gets decreased from 12 to 8. So this was the data that has been provided to us. Using this data, we have to calculate the value of C1, C2 and C5. That is the number of columns in these 3 cases. So for this, first of all, we have concluded that they are in inverse proportion. With an increase, it's causing a decrease. Now, this was not the only condition for inverse proportion. Another condition to satisfy inverse proportion was that the product needs to be a constant. So let me check that first. So in this case, R3 and C3 take the product of 12 and 4. Gives us 48. Again in this case, R4 and C4. Let us take the product of 6 and 8. 6 multiplied with 8 gives us 48. So the product is a constant. They are in inverse proportion. Now let's calculate the value of C1, C2 and C5. So let me write the condition for inverse proportion. The condition was that the product of the first variable and the second variable will be a constant. It can be anything like x1, y1 will be equal to constant. So we can write in this way that x1, y1 will be equal to x2, y2. This product will always be equal. Will be equal to x3, y3. Will be equal to x4, y4. Will be equal to x5, y5. Now from over here in case of x we have r and in case of y we have c. So let us take the first case. We will take r1 multiplied with c1. Now this should be equal to r2 multiplied with c2. This should be equal to r3 multiplied with c3 and so on. We will not take the case of r2 and c2 because here we don't know c2. We will be taking this case, that is r3 and c3. So r1 multiplied with c1 will be equal to r3 multiplied with c3. So from here, r1 is known to us and it is 2. c1 is not known. So we will just write c1. In place of r3, we have 4 and in place of c3, we have 12. So it will be 4 multiplied with 12. Now, in order to calculate c1, I'll be taking 2 on the right hand side and it will get divided. So we have 4 multiplied with 12 divided by 2. 2 gets cancelled out with 4 leaving behind 2 and thus we have 12 multiplied with 4 that is equal to 24. So we can say that when the number of row is 2, the number of column will be 24. In the similar way, let's try calculating the number of columns when the number of row is 3. So again in this case, we can write the product of these 2 variables. That means R2 multiplied with C2 should be equal to the product of the variable in any other known case. Let's take again C3 and R3 and C3. So will be equal to R3 multiplied with C3. In case of R2, we can write 3. C2 is not known to us, so we'll be writing C2 will be equal to R3, that is again 4, multiplied with C3, that is 12. So from here we can get the value of C2 is equal to 4 multiplied with 12 divided by 3. 3 gets cancelled up with 12 leaving behind 4 and 4 multiplied with 4 gives us 16. So the number of column when the number of row is 3 will be 16. Now we have to calculate C5. This is the last calculation that we have to do. So let us take the ratio of this one. That is the ratio of the first variable, the product of this. That means the product of the first variable R5 with the second variable, that is C5. Now this product will be constant. So now this product will be constant with a known quantity. Let us this time take R4 and C4. So will be equal to R4 multiplied with C4. So over here we know that the value of R5 is given as 8 multiplied with C5 will be equal to, we have R4 and C4. R4 given to us is 6 and C4 is 8. So it will be 6 multiplied with 8. Now from here we can get C5 is equal to 6 multiplied with 8 and this 8 will be taken to the right hand side and it will get divided over here. 8 and 8 will get cancelled up leaving behind C5 as 6. So we can say that when the number of row is 8, the number of column is 6. Now in order to check your answer, just multiply these two quantities. 6 multiplied with 8 gives us 48. Is it coming equal? Now 16 multiplied with 3 gives us 48. Again 24 multiplied with 2 gives us 48. So the product is a constant number in each of these cases. So this is the method of solving these types of questions. Now the observation from the previous table was that as the value of R is increasing, that is, it is becoming from 2 rows to 3, 4, 5, 6 and then 8 rows, the value of column, that means the number of column, it is getting decreased. From 24, it became 16, then 12, 8 and 6. So, do you observe as R increases, C decreases? Yes, as R increases, the number of columns decreases. Now, is R1 is to R2 equal C2 is to C2 is to C1? We have to calculate this. Let's check whether R1 is to R2 is equal to C2 is to C1 or not. So, R1 was 2 is 2 means this is a ratio. It simply means that dividing these two quantities. R1 is to R2 is R1 divided by R2. So, R1 over here is 2 and then R2 over here is 3. So, here we have 2 by 3 and let's check for C2 is to C1. So, for C2 is to C1, we will have C2 is 16 and C1 is 24. So, we have 16 and then, C2 is 16, yes, and then C1 is 24. Now, this will get cancelled up. 8 2 times 16 and 8 3 times 24. So, what we observe is that this ratio R1 is to R2 is 2 by 3 and the ratio C2 is to C1 is also 2 by 3. So, both of these ratios are equal. So, the answer will be yes. R1 is to R2 is equal to C2 is to C1. And this is also the condition for inverse proportion, that x1 upon x2 should be equal to y2 upon y1. Isn't the same? Yes, it is. Now we have to check is R3 is to R4 equal to C4 is to C3. Now what was R3? R3 was 4 and we have to take the ratio of R3 with R4. R4 was 6. Now this will give us a ratio of 2 is to 3 because 2 gets cancelled up with 4 leaving behind 2 and leaving behind 3 in case of 6. Now we have C4 is to C3. In case of C4 we have 8 and in case of C3 we have 12. So we have 8 divided by 12. Now 4 2 times gives us 8 and 4 3 times gives us 12. So we are again having 2 by 3. So we can say that yes, R3 is to R4 is equal to C3 is to C4. This ratio is equal in this case as well. So the answer will be yes over here too. The next question on your screen reads that observe the table given below in which there are two variables x and y and you have to check whether x and y are inversely proportional to each other or not. So, for checking that x and y are inversely proportional or not, first of all, we need to know the condition for x and y to be inversely proportional. So, the condition that I taught you was that the product of the variable, that means x multiplied by y, should be a constant number. That means that in each of these cases, when we take the product of the first variable x with the second variable y, then the product needs to be equal in each of the cases. That means over here, we can call this as x1, this as y1. This can be called as x2, this as y2. And in a similar way, we can call this as x3, x4. And this can be called as y3, y4. Now, let us check for each of the cases. So, first case, we have to check the product of x1 multiplied with y1. So, x1 multiplied by y1 gives us 50 multiplied with 5, which is equal to 250. Now, let us check for x2, y2. So, in case of x2, y2, the product is x2 is 40 and y2 is 6. 40 multiplied with 6 gives us 240. The case of x3, y3. So, in case of x3 multiplied with y3, we have x3 as 30 and y3 is equal to 7. So, 30 multiplied with 7 gives us 210. Now, let us check the last case, that is x4 multiplied with y4. So, x4 multiplied with y4 is equal to 20 multiplied with 8, which is equal to 160. Because 8 2 times gives us 16 and 0 is 160. So, what we are observing in each of the cases? That in each of these cases, the product are different. It is not a constant. That means x multiplied by y is not a constant. So will x1, y1 be inversely proportional? No, because it is not satisfying this condition that the product should be a constant number. So x and y will be not proportional. That means not inversely proportional with each other. So the answer will be no, they are not inversely proportional with each other. The next question is a very similar question, just like the previous one. Here also we have been given a table. There are two variables x and y, and we have been given the corresponding values. Now we have to check that whether these two variables are inversely proportional or not. Now you will be telling the condition along with me. The condition for two variables to be inversely proportional with each other is that the product of these variables, that means x multiplied by y, should be a constant number k. Now let's check for each of the cases. So over here, in case of x1 multiplied with y1, we have, now what is x1? x1 is the first value of x. y1 will be the first value of y. So in case of x1, we have 100 and it is multiplied with the first value of y1, that is 60. Now 100 multiplied with 60, it gives us 6000. Now let us solve for the next one. That means x2 multiplied with y2. In case of x2, we have 200 and y2 we have 30. Now we have 200 multiplied with 30. So 3 multiplied with 2 gives us 6 and we have 3 zeros. So again we get 6000 as the product of the two variables. Let's check for the third case. In the third case we have x3 multiplied with y3. Now what is the value of x3? It's 300 and the value of y3 is 20. So we have 300 multiplied with 20. Now 3 multiplied with 2 gives us 6 and we have in total 3 zeros. So we'll again get 6000 as the product of the two variables. For the last case, we have x4 multiplied with y4, which will be equal to 400 multiplied with 15. Now, what is 15 multiplied with 4? It's 16. And then we have 2 zeros. So ultimately, we get 6000. So what do we observe? That the product of the variable in each cases are equal. That means this particular question, the values of x and y, is satisfying the given condition, the important condition for the two variables to be inversely proportional to each other. So we can say that yes, the two variables are inversely proportional because it is satisfying this condition of x multiplied by y is a constant. Because in each of the cases, we are getting the value as 600, the 6000. The product is 6000, which is a constant number. So this product is a constant number and hence our answer will be that yes, x and y are inversely proportional to each other. Now let's solve another similar problem. Okay, so in this question also, we have a table and then we have two values, that means two variables. One is x and the other is y. Now again we have to check the similar thing. That is, x and y are inversely proportional or not. So let me write the condition first. Now I think you know the condition better than me. That is, x multiplied by y gives us a constant number k. Let's check for each of the values of x and y. In the first case, the value of x1 is 90 and here y1 will be 10. So let's multiply. So from here we get x1 y1 is equal to 90 multiplied with 10, which gives us 900. Now let's calculate for the second value. Here we have the value of x as 60 and y as 15. So we can say that x2 multiplied by y2 is actually 60 multiplied with 15. Now over here 15 6 times gives us 90 and then we have a 0. So we get 900 in the second case as well. Let's calculate for the third case. Here we have x as 45 and y as 20. So we'll be calculating, here it will be y2. So here we'll be calculating x3 multiplied with y3. Here x3 is 45 and y3 is 20. Now what is 45 multiplied with 2? It's 90 and a 0. So we get 900 again. Let's calculate for the fourth case, that is x4 multiplied with y4. Now in case of x4 multiplied with y4, x4 is 30 and y4 is 25. So we have 30 multiplied with 25. Now 25 3 times gives us 75 and a 0. That means the answer is 750. let's check for the fifth case. That means x5 multiplied with y5. Now in this case, the value of x5 is 20 and y5 is 30. So we have 20 multiplied with 30. This gives us 3 multiplied with 2 gives us 600. So we get 600. And let us check for the last case. That means x6 multiplied with y6. So in this case, x6 is 5 and y6 is 35. So we have 5 multiplied with 35. Now 35 multiplied with 5 gives us 175. So what do we observe? That in the first case, when we took the product of x1, y1, we got 900. x2, y2 also we got 900. x3, y3 also we got 900. But till here, if the table would have been till here, then we would have said that x and y are inversely proportional. But what is happening from the next point? From x4, y4, the value of this product is changing. It is becoming 750 in case of x4, y4, and in case of x5, y5, it is becoming 600 and then 175. So we can see from over here that this value, that the product of x and y, this multiplication of x and y is not a constant case. So x and y will not be in inverse proportion with each other. The answer will be no. Just make an observation over here. The value of x, what is happening? From 90, it is becoming 60, 45, 30, 25. That means the value of x is decreasing and the value of y, it is increasing. From 10, it is becoming 15, 20, 25, 30, 35. So, x is decreasing, y is increasing. But still, it won't be in inverse proportion. So, one thing is very important to conclude from here, that for two variables to be inversely proportional to each other, it needs to satisfy two criteria. That means the first criteria is that if one variable is increasing, the other variable should decrease, or if one variable is decreasing, the other should increase. But the product of the two variables should be a constant. That means x1, y1 should be equal to x2, y2, should be equal to x3, y3, and this should be a constant number. So this is a very important thing. Over here, just by seeing this, that x is decreasing and y is increasing, you cannot conclude that this is an inverse proportion. You have to check this necessary condition. That means the product is a constant or not. So just keep this in mind while solving the numerical problems. Now that I have taught you about direct and inverse proportion, this question might come into your mind that every time while writing this questions or while solving the problems, do we have to write x is directly proportional to y or x is inversely proportional to y? Do we have to write so much in mathematics? Well, no. Answer is no. You don't have to write these big statements in mathematics. For everything in mathematics, we have some simple symbols to represent them. So, what can we write in place of x is directly proportional to y? What can we write in place of this? X is directly proportional to y can be written as x, and then we have to give this sign. This sign is the sign of proportionate. So x is directly proportional to y. It is quite simple. So now I think you all must be happy that you don't have to write those big statements in mathematics. So this is the way to represent that x is a variable and y is a variable, and both of them are directly proportional to each other. So whenever you find this thing in the question, you just get to know that x is directly proportional to y. Now another thing, what is the case of inverse proportion? What if I have to write that x is inversely proportional to y? For this also we have a very precise thing. Now just look at over here. We have to write x and we have to use the same symbol. The symbol will be same. This will be like this. But here in the case of inverse proportion, what we have to write is, x is inversely proportional to y. So we can say that 1 by y, because 1 by y means y inverse. So x is directly proportional to y inverse means that x is inversely proportional to y. So this is the symbol or a simpler way of representing x is inversely proportional to y. You have to write x, then give a proportionate sign and then write 1 by y. So whenever you find this, just get this idea that it is inverse proportion, and whenever you have that x and then proportional sign y, then that means that that is directly proportional. In other words, we also say that x varies indirectly with y, and in this case we say that x varies inversely with y. So this is another statement that we can use for two variables in direct and inverse proportion respectively. Now you have a question to solve. So the question on your screen reads that 6 pipes are required to fill a tank in 1 hour 20 minutes. How long will it take if only 5 pipes of the same type are used? The very first thing in these type of question is to figure out that whether the question is of direct proportion or inverse proportion. So let me give you a simple example. You are taking a shower and then you have a bucket to fill. Now you're waiting for the bucket to get filled. If you had an option of one more tap and you just turn on that tap, then the time taken to fill the bucket will get reduced. So if we increase the number of taps from 1 to 2, then the time taken gradually decreases. The same thing over here. If I have 6 pipes and 6 pipes is requiring 1 hour 20 minutes to fill a particular tank. Now if I am decreasing the number of pipes to 5 pipes, will it take more time or will it take less time? Use your common sense. It will of course take more time because the number of pipes is getting reduced, so the time will increase. What is this? This is inverse proportion. That if one variable is increasing, then the other variable will decrease. Or here what is happening? The number of pipes is decreasing, then the time taken will increase. So we have to actually calculate the time taken when 5 pipes are there to fill the tank. So just remember that the time will always come less than 1 hour 20 minutes. Because when we have, it will always come more than 1 hour 20 minutes. Because when we have 5 pipes, then the time taken will be more than that when we had 6 pipes. So first thing is that convert this 1 hour 20 minutes into minutes. Now 1 hour can be written as 60 minutes. So 1 hour 20 minutes can be written as 60 minutes plus 20 minutes, which is equal to 80 minutes. 80 minutes. Now, in these type of problems, the best thing you can do is construct a table. That will make your question much more easier. So the first variable given to us is the number of pipes and the second variable given to us is the time taken in minutes I have taken. So when I had 6 pipes, the time taken was 80 minutes. I just calculated, I converted this 1 hour 20 minutes into minutes and it gave me 80 minutes. So when there were 6 pipes, it took me 80 minutes. Now the number of pipes that I have is 5 and I have to calculate the time. So let the time taken be x minutes. So I have over here as x minutes. So what will I fill in this box? X. X is the time taken to fill the tank in when I am using 5 pipes. Now, just because this is inverse proportion, so we need to just recall the connection. That means the necessary condition for two variables to be in inverse proportion. What was that? Let me give you a quick recap. We had that the product of the variable x and y should be a constant number. That means x1 y1 should be equal to x2 y2 in that way. Over here, x1 is this. Let us consider this as x. This is just for the sake of convenience, just for yourself. You won't be writing this in exam. Just consider this. And this is y. Now you have x and y. So this is the value of x1 and this is the value of y1. Let us take the product of these two. So we'll have x multiplied with 18 and this will be equal to x2 y2, the product of these two variables. So we'll have 5 multiplied with x. So this will be our equation according to the problem. Because according to the problem, we got to know that these two things, the number of pipe and the time taken, they are inversely proportional to each other. So their relationship will be that the product of the two variable will be a constant. Now from over here, we will calculate the value of x. What we have to do is very simple. We have to take x on the left hand side and all the other things on the right hand side. So when we take all the other things on the right hand side, we are left with 6 multiplied with 80 divided by 5. Now this 5 can get cancelled out with 80. So 5 1 times and we have 5 16 times 80. Now what you have to do? You have to multiply 6 with 16. Now 16 multiplied with 6 gives us 96. So we have the value of x as 96. Now x is given in minutes because it is time. So it will be 96 minutes. So we can say that the time taken when we have 5 pipes to fill the same tank will be 96 minutes. Now let's convert this 96 minutes into hours and minutes. Now we know that 96 can be written as 60 plus of 36 minutes. Of course I can write it like this. Now we all know that 60 minutes is equal to 1 hour. So it will be 1 hour and 36 minutes. Just observe the final answer and this 1 hour 20 minutes. What is happening? When we had 6 pipes, the time was 1 hour 20 minutes. Now the number of pipe has reduced to 5 and the time taken has increased to 1 hour 36 minutes. So it is taking, I will say that 16 minutes more time, because earlier it was taking me 1 hour 20 minutes. Now it is taking me 1 hour 36 minutes. So the time taken has increased by 16 minutes when the number of pipes has reduced. So this is the way of solving these types of problems. The next question on your screen reads that in a hostel there are 100 students and food provisions are there for 20 days. That means enough food is there in the hostel that will last till 20 days for those 100 students. Now it has been given that more 25 students are added to the hostel. That means now the number of students is 100 plus 25. That means 125. So we have to calculate the total number of days for which the food will last for these 125 students. The first thing is to understand whether this question is of direct proportion or inverse proportion. So for this, let me give you a simple example. You bought 2 packets of chips for yourself, okay, in a hope of eating one today and having the other the next day. Now if a friend comes to your house, then what will happen? Your chips packet will get finished up today itself. It won't last for tomorrow. So from here we can conclude that the number of people increased. From 1 it increased to 2 because your friend accompanied you. But the number of days that the chips will last got decreased. It would last for 2 days if you were alone. But now that you have another friend with you, it lasted for just 1 day. So as the number of people increased, the number of days for which the food will last became less. That means it decreased. So between these two variables, that means the number of people, or here in this question we can say the number of students and the number of days, there is an inverse relationship. If the number of students increase, then the number of days for which the food will last will decrease. So this is the relationship. So what is it? It is an inverse proportion. So let's, for solving these type of questions, the first thing is to construct a table because this makes our calculations and problem much more easier. So in the first case, the number of students initially were 100. When there were 100 students in the hostel, food provisions were enough to last for 20 days. So the number of days will be 20 over here. These are the two variables. Next up, we have that now the number of students have increased. That means it has become from 100, it has become to 125 because 25 students are added. So we have 100 students were initially there. And we have no more 25 number of students. So this gives us 125 students. So we can say that the number of students have now increased to 125. And we have to calculate the number of days for which the food will last in the hostel now when there are 125 students. So let us consider that the number of days, let the number of days for which food will last be x as usual. So we have over here x is the number of days for which the food will last for 125 people. Now the first part is being solved, that we have understood that this is a question of inverse proportion because as the number of students will increase, the number of days will decrease. This food will last for less number of days now that we have 125 students instead of 100 students. So we will apply the condition. What was the necessary condition for two variables that are in inverse proportion? The product of these two variables was a constant number. So this is what I taught you previously. Now we'll be including this property in this question and solve it. So what we'll have over here is, here x1 y1 will be equal to x2 y2. In place of x1 we have, so we can write according to the problem, we have x1, that is the first variable, that is 100, multiplied with y1, that is 20, will be equal to x2 y2, that means 125 multiplied with x. From here we can easily solve x. We have to solve x, we will be taking x on the left hand side and all the other quantities on the right hand side. So we are left with 100 multiplied with 20 divided by 125. Now we can cancel 100 and 125 by 25. 25 5 times gives us 125 and 25 4 times gives us 100. Pi 1 times pi 4 times 20. So we are left with x is equal to 4 multiplied with 4, which gives us 16. So we can say that x is equal to 16. That means if instead of 100, I am having 125 students in the hostel, then the amount of food that is present in the hostel will last for only 16 days. Earlier, when there were 100 students, it was lasting for 20 days. Now when there are 125 students, it will last for only 16 days. So as the number of students are increasing, the number of days for which the food will last gets decreased. So this is the concept of inverse proportion. The next question on your screen reads, if 15 workers can build a wall in 48 hours, how many workers will be required to do the same work in 30 hours? I'll explain it to you. What we have two variables in the question. One is the number of workers and the second is the time taken in hours. So it is given that we have to build a wall, and if I have 15 workers, then it will take 48 hours to build the wall. So what I can write is, if the number of workers is 15, then the time taken to build the wall is 48 in hours. Now what I have to calculate is, I have to calculate that how many workers will be required. That means the number of workers to build the same wall in 30 hours. This means that I have to build the same wall, but I have less time with me. Instead of 48 hours, I want the wall to get built within 30 hours. So now I have to calculate how many workers do I need to get the work done, that is to get the wall built in 30 hours. Suppose I have a piece of work and it will take me to finish it I guess 10-15 minutes, but I wanted to do in 5 minutes. What will I do? I'll take a help of another friend of mine. So I'll increase the number of people in order to reduce my time. So what is the relation over here? The relation over here is inverse proportion. That means if the number of workers will be increased, then the time taken to finish a piece of work will reduce. So this is a question of inverse proportion. So the first thing we have figured out. Now what we have to do? We have to construct a table as we have done in the previous questions, and we have to write the variables. The first variable is the number of workers and the second is the time taken in hours. So when there were 15 workers, it was taking 48 hours to build the wall. Now we have to calculate the number of workers which needs to be employed in order to build the wall in just 30 hours. So let me take that, let the number of workers be x. Let the required number of workers be x. So over here, the number of workers is x, and these x number of workers will finish the work of building the wall in just 30 hours. Now, I already told you that this is a problem of inverse proportion, because increase in the number of workers will cause a decrease in the working hour, decrease in the time in which the wall will be built. So in inverse proportion, we know the necessary condition is that the product of the variable should be a constant. That means x1 y1 should be equal to x2 y2. Over here, x1 y1 means x1 is 15. So we'll write according to the problem, we have x1 is 15 and y1 is 48. So 15 multiplied with 48 will give us x2 y2. That means x multiplied with 30. So from here, we can calculate the value of x by taking it on the left hand side and all the other quantities on the right hand side. So we have x is equal to 15 multiplied by 48 divided by 30, because we took 30 on the other side, so it will get divided. Now 15 1 times, 15 2 times gives us 30, 2 1 times, and 2 24 times gives us 48. So from here we get the value of x as 48. The value of x is 24. Like 2 gets cancelled up with 48, leaving behind 24. So the value of x is 24. Now that we have 24, so this is our final answer. That means we need 24 workers. Earlier we had 15 workers. Now we need 24 workers if we need to complete the work of building a wall in just 30 hours. So I hope the problem is understood and you will be able to solve similar problems of this type. That was the end of today's session. We'll be meeting in the next video where I'll be discussing few recap points of the entire chapter, the important points, and we'll be getting through a quick revision. So hope to meet you in the next video. Thank you for connecting me on Study Room.